Matematika. Today we're going to do problems and solutions of 1.11b, equivalent representation of polynomial and rational expression. We'll start with the first set. Use the binomial theorem to expand the following. We have x plus 3 raised to the third power. Now what I'm going to use here is the binomial theorem and combining it with the Pascal's triangle. I'm not going to use the factorial. I'm trying to make the solution as shorter as I could when doing the expansion of a binomial theorem. All right, so we'll start. Let's identify first the n. The n here is 3. The first term is x. The second term is 3. All right. So I'm going to do the summation of from r equals 0 to n. That is the summation from 0 to 3. So I start with 3, choose 0. Then the first term times the second term. I'm going to do that first. Then I will assign the exponent later. 3 choose 1, first term, second term. 3 choose 2, first term, second term. Then 3 choose 3. That would be first term, second term. Now take note that in terms of the exponent, the first term, the exponents are descending. So from 4 goes down to 0. So that means I start from 3. So I have 3 here. Then next descend to 2. Then 1. Then 0. Okay. The second term is ascending. That means from 0 to n. I'll start with 0 here, then 1, then 2, then 3. Take note that when you add the exponents, they sum up to 3. Next is to look for, I have a Pascal's triangle here. You look for the row 3 since our n is 3. So the row 3 is here. Because this is 0, 1, 2, 3. What are the terms in row 3? We have 1, 3, 3, 1. Okay, we are ready. 3 choose 0. I will replace that with 1. Because when you look at the Pascal's triangle, that's the term of 3 choose 0. Then x to the third times 3 to the 0, that's 1. 3 choose 1 is 3. Okay. Then x to the second, 3 to the first. Okay. Plus 3 choose 2, it's 3. Then x to the first, then 3 to the second, that is 9. Okay. 3 to choose 3 is 1. Times x to the 0, it's 1. 3 to the third, 3 times 3 times 3, that's 27. So let's simplify. X cubed, 3 times 3, that's 9x squared. 3 times 9, that's 27x. 1 times 1 times 27. This is the expanded form of x plus 3 to the third power. See? You don't need so many stuff doing the factorials each time. Okay, let's have number 2. Let's identify the n. n is 4. First term is 2x. Second term is -1. Okay, I'm gonna start. I have to look first the coefficient here, the terms. In the fourth row, it is 1, 4, 6, 4, 1. Okay, it's symmetrical. All right, I'm gonna start my summation of from 0 to n, so 0 to 4. It will be 4, choose 0. I'm gonna write first the terms, then 4, choose 1, 2x, -1, then 4, choose 2, 2x, -1, then 4, choose 3, 2x, -1, then 4, choose 4, 2x, then -1. Okay, let's assign the exponents. So the first term, it is descending. So start from 4 here, then 3, 2, 1, 0. Well, the second term is ascending. So from 0, 1, 2, 3, then 4. All right, we have that. Okay, now substitute where the location of the term is. So 4 choose 0, it's 1. That is our coefficient. 2 to the 4th, 2 to the 4th, that is 16. X to the 4th, then -1 to the 0, it's 1. 4 choose 1, it's 4. Then 2 to the 3rd, that is 8. 8 to the 3rd. -1 to the second power, that's +1. Okay. To the first power, I mean. That's -1. Okay, this is -1 right here. Plus 4 choose 2, it's 6. 2 squared is 4, x squared. -1 squared, that's 1. Plus 4 choose 3, that is 4. Then we have 2x. -1 to the 3rd, that's -1. Plus 4 choose 4, it's 1. 2x to the 0, that's 1. -1 to the 4th, that's 1. Okay, so let's simplify. Our first term here is 16, x to the 4th. 4, okay, we have a negative. 4 times 8, that's 32, times -1, that's -32, x to the 3rd. 6 times 4, that's 24. Okay, cancel out this. Oops, sorry, I messed out. Nothing is cancelled. This is from the other one here, it's plus. What did I do? Plus, then times 1 times 1 times 1. All is 1 here, times 1 times 1. So negative 2x to the third power. Where am I now? Okay. So the second here is plus 24x squared. Then the third is 4 times 2, it's negative 8x. Then plus 1. It's not cancelled. Right. Plus 1. This is the expanded form for 2x minus 4. Let's have the third one. N is 5. A is 2x. Second term is 1. Okay. So I'm looking at the coefficient of the row 5 since our n is 5. So I have 1, 5, 10, 10, 5, 1. Okay, I'm going to start. 5 choose 0. I have 2x and 1. 5 choose 1. I have 2x and 1 here. 5 choose 2. 2x and 1 plus 5 choose 3. 2x and 1 plus 5 choose 4. 2x and 1. 5 choose 5. I have 2x and 1. Then I will assign the exponents. Okay. The first term is descending. So I'll start with 5. So this is 4. This is 3, 2, 1, 0. Well, the second term is ascending. So it starts with 0, 1, 2, 3, 4, 5. All right, you have that. All right, let's do this. 5 to the 0, it's 1 times 2 to the 5th, that is 32, x to the 5th power. 1 to the 0, it's 1. 5 to the 5 choose 1, it's 5. Then 2 to the 4th, 2 times 2, it's 4 times 2, 8 times 2, 16. All right, this is 4. I have to check. 2 to the 4th is 16. Okay, x to the 4th times 1. Then 5 choose 2, that's 10. 2 to the 3rd, it's 8. X to the 3rd times 1 plus 5 choose 3, that's 10. 2 squared, it's 4. X squared times 1. 5 choose 4. Let me see, I'm checking. 5, 4, 3, 2. Okay, 5 choose 4 is 5 times 2x times 1. 5 to the 5th, it's 1. 2x is 1. 1 to the 5th, it's 1. All right. So let's have the whole thing. So the first term is okay. So it's 32x to the fifth power. That's the first term. 5 times 16, that is 80. X to the fourth. 10 times 8, that is 80. X to the fifth power. Plus 10 times 4, that's 40. X to the third, I mean, this is third. 40x squared. Then 5 times 2, that's 10. X. Then plus 1. Ooh. So 5, 4, 3, 2, 1. I'm checking on the exponents if I mess out 1. So this is supposed to be 3. All right, we have that. Now this set is asking you find the given term in the binomial expansion. That means you're asked to whatever possible term that is, like number 1, for example, x plus 3 to the fifth power. Okay, remember that finding the term, you were given this formula, right? N choose r minus 1, and then you have a n to the power a to the power of n minus r minus 1, and b r minus 1. Let's not do the counting because you might be confused. I will go direct to the point here. So if you have 5x plus 3 to the fifth power, so we'll go straight, look at the fifth row. Okay, the fifth row is here. And we are asked with the fourth term. So where is the fourth term? 1, 2, 3, 4. 10 is our fourth term. So we're gonna write it fourth term. R, that is n, that is 5. Choose 4 minus 1, that is 3. So 5 choose 3, that is 0, 1, 2, 3. Okay, so 10, and then a, that is x, a here, n is 5 minus r minus 1. What is our r? R is 4, n is 5. All right, so that would be to the second power. Okay, that is n. I'm going to write it here again. So this is the fourth term of the row. And then the first term, which is x, it should be n. Our n is 5 minus r. R is 4 minus 1. And our second term is 3. That is r minus 1. So our r is 4 minus 1, that is 3. So that means we have 10. 5 minus 3, that is 2. And then 3 to the third power. Oops, I made a mess. Five minus 3, it's 2. Then our second term is 3 to the third, which is 10 times 3 to the third is 27 x squared. That is 270 x squared. All right, let's do this. N is 6. First term is 3x. Second term is negative 2. Okay, let's look for the fifth term. So R is 5. So let's look for the fifth term in the Pascal. Sixth row. 1, 2, 3, 4, 5. Right here. So that would be 15. Then our first term, the exponent should be the n, which is 6, minus the r is 5 minus 1, that's 4. So 6 minus 4, that is to the second power. Okay? And then the negative 2 has the exponent 4. All right. Let's simplify. 15. 3 squared is 9 x squared. Negative 2 to the power of 4. That is 2 times 2, 4 times 2, 8 times 2, 16. Okay? So that is 15 times 9 times 16. Multiply in the calculator. We have 2160 n squared. That is the fifth term when you try to expand that value. All right. I'm checking if I messed out something here. Okay. In letter C, what is the leading coefficient of the fourth term of x minus 2 raised to the 6th power and expanded? So leading coefficient of the fourth term. So let's look at the, all right, I'll have it as, what is our n here? N is 6. We have the first term as x, and the second term is negative 2. And then the 6th row, okay, I'm gonna have it here. Fourth term for that, 1, 2, 3, 4, that's 20. Okay, so I'm gonna start with 20, and then the first term would be n, that is 6, minus r is 4 minus 1, so that would be 6, choose 3, because that would be n is 6, minus n, okay, wait, our r is 4, so 4 minus 1, okay, and the negative 2 is 4 minus 1, so whatever that be, so that would become x6, 4 minus 1 is 3, then negative 2 to the third, so you have 20 x to the third, negative 2 to the third power. Okay, just follow the formula to write that. 2x to the third negative 2, that would be a negative 8. Negative 8 times 20, that's negative 160 x to the third power. But you are asked the leading coefficient, so the answer here is negative 160. Okay, let's solve letter B. What is the second term for 2a minus b to the fourth? Okay, do the same thing. Our n is 4, r is 2, and then first term is 2a, second term is negative b. Okay, let's look for row 4. Second term of row 4, we have 4 right here. All right, so we have 4 second term. Okay, so I'm gonna write, and then that would be our first term 2a minus 2 minus 1, that is 4 minus 2 minus 1, and then the second term is negative b, 2 minus 1. So 4 to the power of 2a okay, so that would be did I mess up something here? Second term, so 4 minus 2, that this will be 3. Okay, because that is 4 minus 1, that's 3. And then r minus 1 is 3. R minus 1 is, okay, let's do this. R minus 1 is 1. All right, so we have 4 times 8a cubed. B is not b to the third, it's b. So that would be 32. This is negative b, so negative 32a to the third b. And that is number 1 right there. All right, let's do this. In the xy plane, the graph of a function f has a limit as x approaches positive infinity, the function of x approach positive infinity. Which of the following could be the expression of f of x? Okay, let's look at the first one right here. This is to the third power. In x times x cubed is x to the fourth power. So the m is less than the n. You know, the horizontal asymptotes, degree of numerator is less than the degree of denominator. So we have, this is not the one. No, we have a horizontal asymptotes here. And that is when it's less than the y equals 0. In this case, negative 2 x to the third, then x to the first power, we have a degree of x to the fourth. So, and the leading coefficient is negative. So we have a degree of even and negative leading coefficient. So what we have is an arrow that is both facing down. So it never happened that the limit would have equal to a positive infinity, because both of them are negative. So this is a no. For C, this is to the third x to the fourth. The denominator is also x to the fourth. So we have same degree, same exponent. So that is when m equals n, case 2. That means we have a horizontal asymptote in this case. So when you are given a problem like this, you have to look at each choices, whether it answers the possibilities. So in a horizontal, when they are equal, you have to get the coefficient, the ratio of the coefficient. So our coefficient, our asymptote here is equals to 1, because this is 1 over 1. While this is x, then this is x to the third, that means x to the fourth, this is x to the fifth. So we have an odd exponent, and the leading coefficient is positive. So add positive. So one arrow goes up and one goes down. All right? Because it's add positive. So in the right, positive infinity has a function of equals to a positive infinity, because it's going up right there. So therefore, this answers the question about this, having this limit. Okay. Find the last term of a minus 2b to the fourth power. Last term. So how are we gonna write this last? Okay, we still have one. Find the third term of x plus y equals 9. X plus y. Okay, so what would be our term here? We have x. This is 3y. So we have n as 9. First term is x. Find the third term. R is 3. Second term is 3y. Okay, looking at the table, if I have the formula of, I have 9, 3, 9, choose 3 minus 1. So it would be A, 9 minus 3 minus 1. And B is 3 minus 1. So what would that be? 9, choose 2. Right? So the A there is 9 minus 2, that is 7. B to the second power. So what is 9 choose 2? Let's look at that in our right here, row 9. And then 0, 1, 2, that's 36. Right? So that is 36, a to the 7 Oh, wait, I have to change that a to the first term as x to the 7, and the b is 3y squared. So that is 36. X to the 7, 3 squared is 9y squared. 36 times 9, that's 324. X to the 7, y to the second power. Okay, that's it. And the last, we have a minus 2b, and the r, the last term, fourth. Let's look at the n is 4. The first term is a, the second term is 2b. Let's look at what the last term would be. How many terms are there in the row 4? Let's look at row 4. 1, 2, 3, 4, 5. So there are 5 terms in row 4. So R is 5. So that means we can write that as 4, that's n, and the R is 5 minus 1, and the A is 4 minus 5 minus 1, and the B is 5 minus 1. Okay, let's replace. That should be 4, choose 4. A would be 4 minus 4, that is A to the 0, B to the 4th. So what is 4 choose 4 in the Pascal's triangle? 4 choose 4. Where is the 4th here? 1, 2, 3, 4, right there. Okay. So that would be 16. A to the first, it's 1, times B to the 4th. This is your last term. So if you're going to do that and do the expanded form by doing like a minus 2b 4 times, you can do that. So these are some of the problems, and we have the solutions for binomial theorem and Pascal's triangle. And let me say this, if I can do it, so can you. So please hit the like button and the subscribe button. See you in my next video.